software cost estimation, is it a friend or foe, especially to Agile software developers? Let me give you a little bit about my background. Who am I? I'm a project management professional, PMP. I'm a certified function point specialist, and I've got a fellow designation, which means that I've been doing this for more than 20 years and certified for that long. I'm a certified Scrum Master, and I'm also a professional engineer. And the only reason I mention those is that I didn't start out in software development. And so coming from an engineering background, computer science and a lot of the development was kind of an anomaly to me. It was kind of this black box. And so now being on the inside, having done software development and software management consulting for so many years, I realized that we still have a gap in different industries between different portions of what we do. And Agile software development is no different. There are boundaries between software cost estimators and Agile software developers, who I call Agilists. There are boundaries between product owners and things. And so what I'd like to do today is really bridge the gap between the software cost estimating side and Agile software development. So I had what I would call the contract of a lifetime. For years and years, probably 10 to 15 years, I would be out somewhere doing measurement consulting. I would be teaching function points or teaching software measurement and the best way to get into it, or project management. And people were writing books. I had the good fortune of running into and working with a lot of different people at conferences and just throughout the world. I do work in international standards development. And I'd meet these people and they'd say, hey, Carol, you're working on function points and you're working on measurement. I'm writing a book on software cost estimation or some aspect of it. So this includes Capers-Jones, Dick Studsky, Dr. Barry Beam. All of those people would, pick my brain on measurement. We'd have dinner or something, and I'd end up getting one of their books. So for 10 to 15 years, I had every move I made, I would take this box of software cost estimation books around with me. And I'd say, I'm really not sure what I'm going to do with these, but they're very interesting to have. And then I was volunteering with ICEA, the International Cost Estimation and Analysis Association, ICEA, and working on a curriculum as a volunteer to pull together a software cost estimation body of knowledge. And the president of the association said, you know what, Carol, this volunteer work isn't going, as speedily and as streamlined as we would like it. Would you consider taking a year and working on this full time? And I said, wow. He actually said, would you take 6 months and do this full time? But it ended up stretching to a year on a fixed price. But I was the lead author of the International Cost Estimation Analysis Association's Software Cost Estimation Body of Knowledge, and I learned a lot. And I ended up being the ICEA 2022 Educator of the Year, which was an incredible honor. I'm the past president of the International Function Point Users Group. I've been an International Standards Organization project editor for software engineering standards for the last, 28 years. Founder of my own firm called Quality Plus Technologies, Inc. And I've spoken in over 30 countries as a global consultant, a published author, thought leader, speaker. So I think I have a little bit of information. I've had people say, Carol, we gain a lot from your presentations. I even had somebody come into a workshop one time, sit through the entire day workshop, and at the end of the workshop come up to me and say, I didn't get my certificate. And I said, well, what do you mean? You're not on, I looked on my list of participants and they weren't on my list. And the guy said, oops, I attended the wrong workshop. He said, I was wondering why I got so much more out of it than I thought I would. So that was kind of an interesting thing. I live in Florida, which is this is my picture on the left-hand side. It's a beautiful place to visit. It's an even better place to live. So let's get into it. What is the current state of software development? And if you're a developer, you may have mixed feelings about this, but let's take a look at this. So from a software development project perspective, what is the status quo? Where are we at? Well, when we look at software project success, according to the Standish Group, which produces this thing called the annual or semi-annual chaos report, and it used to be public knowledge, you could get it for free, and the latest one that you could get for free was in 2015. But through the years since 1996 through to today, and including 2021, 2022, these numbers have not changed. So project success rates in terms of Agile versus Waterfall, whether it's Agile or Waterfall, look at that. Successful projects are only 42%. Oh my gosh. So that means, are you going to invest in my software development project? If I can only guarantee that I'll actually finish it and be successful 42% of the time. And in Waterfall, it's only 1 in 4. What about challenged projects? Challenged projects, 50%, 50-50. Waterfall is actually a little bit higher for challenged projects, much higher for the failed projects. But who wants to invest in your project if 1 in 5 are going to be outright failures? Now, let me step back and tell you what they mean by successful versus challenged versus failed. Successful means the project finished on time and on budget and met the user's needs. A challenge project meant that it was over budget and or over schedule, behind schedule, and or didn't meet the customer's needs. Now, an outright failure means that it was canceled, the funding was stopped, or it just was way over budget, way over time. That's not a really good situation for software developers. Well, let's take a look at the software project growth. And when you look at the differences between, say, software projects and other types of projects, and you look at like the Olympics is often known for being way over budget, way behind schedule. We can take a look at things like NASA or DoD. They have a big growth rate. They've got a lot of cost. It's really common in software because software is such an amorphous situation. We can't touch and feel a piece of software. We often end up with massive growth, massive schedule delays. So this isn't a really good situation for us, but it's better than you think. Top 10 reasons for project challenges and failures, and this comes from a Crosstalk article, but the Chaos Report publishes the same types of things. Poor user input, stakeholder conflicts, vague requirements. Yeah, those all contribute to ending up over budget and behind schedule. But look at this, and this is something that I just went, wow. Poor cost and schedule estimation. That's really a supplier issue. Our estimates are typically overly optimistic. They avoid or ignore risks and the impact that that can have on projects. And the hidden costs of going lean and mean, we can end up with these unrealistic goals and resources. Wow, poor cost and schedule estimation. Think about it. So if I put out a overly optimistic estimate, which eventually becomes a part of the price to win or my contract, if I'm overly optimistic, it's no wonder I'm going to be over budget and behind schedule. That's like a no-brainer. Wow. So if we get better at our cost and schedule estimation, it's going to only make sense that we're going to end up with a higher level of success without doing anything different. This was astounding to me to realize that poor cost and schedule estimates contribute to really poor and impossible contracts. But in software development, that's sometimes hard to realize, especially from a management perspective. Well, what's the impact of these unrealistic estimates? And an unrealistic estimate I define as being overly optimistic. The cost is unreasonably low, the duration is too short, and it overlooks in terms of avoids or ignores risk. What's the impact? It's kind of like building a bridge. And I've seen these in other countries that is half done. We'd never do that in construction, or we plan not to do it. The Standish Group, which is the Chaos Report on US government and business, said canceled software projects contribute $81 billion of spending. Wow. 59 billion due to budget overruns. Wow. So if we knew what it would really cost to really be able to build in the first place, there might be different decisions. We might invest in the right way. And if you've got a contract where the budget or the target is absolutely realistic, it's going to be a much better project in the first place. Well, back in years ago, I thought about this and I thought, this kind of reminds me of what happens in either a hurricane, because I live in Florida, or like a dog chasing its tail. Unrealistic estimates lead to poor project outcomes. So we're going to start out at the very beginning of a project. We've got high-level requirements, or we might not even have really a product backlog. We might have a little bit of it, but we've really got few strong inputs. We've got really low estimating maturity. Somebody in a back room says, oh, I've got a spreadsheet. But we don't have strong inputs. Sometimes we haven't even documented our assumptions of what should go into that budget or what should go into the estimate, which leads us to weak or unreliable estimates, which leads us to unrealistic plans for cost, effort, duration, which leads us to impossible contracts or internal projects, which, surprise, lead to out-of-control projects. The adverse project outcomes are uncontrolled project growth because we haven't planned for it. Failed and canceled projects, litigation. I tell people there is no such thing as a win-lose contract. If the supplier wins and the customer loses, that's really a lose-lose contract. We either have win-win or lose-lose contracts. And the only people making money from these projects that go out of control are the litigators, are the lawyers. We end up with wasted investment. Wow, this is pretty major. But you know what we do then? When we start a project and we go, oh my gosh, we've got changes coming, or we're on an Agile project and we're working through it, and we have to deliver a certain amount of value in a certain number of sprints. Oftentimes what happens, whether it's Waterfall or Agile, is we throw it over the fence and we say, okay, we're going to deal with that in the next release. And what happens? Again, we do few strong inputs, a low estimating maturity. We don't change anything. And this truly, to me, is like a dog chasing its tail. We're smarter than that. We should be able to do a better job on this. Okay, but isn't Agile development by its very nature unpredictable? There's a whole movement of no estimates because estimates become targets. So why should we even bother estimating in the first place? Well, you can take that attitude, but guess what? Anybody in management, especially in government management, in the federal government, has to make plans 2 to 3 to 4 years in advance. The acquisition life cycle starts out way in front. They need estimates as the basis for going forward. You might not agree with it. You might say it's way out of line. We've got our uncertainty, cone of uncertainty. You can resist it all you want, but management still needs estimates. So instead of fighting it, there's ways around it. So I present to you 10 lessons learned that I learned going through the process and working with professional software cost estimators whose livelihood depends on creating data-founded, solid software cost estimates that can then be turned into pricing or contracts or budgets. I had no idea there was this much to it. but they are absolutely professional. They take 2 to 3 months in some cases to come up with a estimated cost or schedule. So here's the lessons, the top 10 lessons I learned about software cost estimation. And we have embroiled all of this into essentially, I think it's about 1,000 PowerPoint slides in the upcoming software cost estimation body of knowledge, which I'll talk about at the end. So number one, historical data-based estimates are way more reliable than theory or guesses. You've probably heard the term that Einstein, or the phrase that Einstein said, which is insanity is doing the same thing over and over and expecting different results. So I'll go in and I'll work with a project team and I'll say, so what's going to be different on this project? And they go, we're going to finish on time. We're going to finish on budget. We're just going to do that. And I go, oh, okay. So do you have different people? And they go, well, no. I go, do you have different tools? And they go, well, no. Do you have different users? No. Do you have a different process? No. But this time it's going to be different. Well, that's not true. And if you go to a theoretical model purely, whether you're using a sophisticated software cost estimation tool or a spreadsheet or COCOMO, those tools need to be calibrated. So data analysis is absolutely important. The data must be similar, it must be relevant, it must be comparable. So if we look at historical data, we need to have actuals. We need to be able to do estimating by analogy. We need to compare a kind of sort of project that was completed to what our new project is. And to use purely a theoretical model isn't going to work. Data normalization is absolutely critical. In terms of units of measure, the scope, the who, what is overtime involved. Now, we can go in and size something using function points, or some people use source lines of code. We can size the piece of software we're going to develop. And then we can take a look at, okay, what's the historical project hours? Now, I know that every hour is 60 minutes and every minute is 60 seconds. So people will say, oh, this project took us 1,000 hours. And this other project took us 5,000 hours. Okay, so what do those hours mean? Do they include overtime or not? Do they include only full-time equivalents, or does it include the consulting hours? Does it include the tasks to develop a project from scratch, from requirements all the way through to deployment? Or does it only include taking your prototype and elevating it into production? What does it include? We need to make sure that we've normalized the data on which we're comparing. Historical data are absolutely valuable. It tells a factual story in terms of a cost estimating relationship, that's what a CER is, or a schedule estimating relationship. And it's not going to be a linear relationship. So I can't take a project of a certain size times a magical number and come out with, here's the amount of time it's going to take to do it in terms of cost, effort, and schedule. So that's number one. Number two, my mouse is jumping ahead. Number two, there's a cost estimation maturity model. And most companies, rightly or wrongly, are at level one, where we have an informal or no formal process in place to do software cost estimates. So we don't either we don't have any estimation processes, or estimation is performed in an inconsistent manner, or it's a wild guess, or we're using expert judgment as the only input, or we're doing task-oriented expert judgment, or we end up with poor estimates and plans because it's in somebody's back office on their Excel spreadsheet. So to become a higher level, we really need to introduce a formal sizing technique. So how big is this piece of software we're going to develop or enhance? That's important. So as you move up the levels, it's similar to the capability maturity model, which the Software Engineering Institute had years ago, but introducing a formal sizing technique instead of, oh, this project is big, let's compare that to another big project, or this is a colossal. How big is colossal? Doesn't make sense. So many companies don't follow any sort of formal estimating practices. And this is something you can take back to your company to say, you know what, we really need to have formal software cost estimating. We need to base it on data that we've collected. Now, you may not have any data that is very valuable today. Capers-Jones says, who's a leading author in the area of software cost estimation, measurement, anything to do with software development. And he says the data that we have collected in the software industry is the worst data in the world of any professional endeavor. So we can start by collecting good data on which to build future estimates. So this is number 2, cost estimating maturity model. If you're like 90% of the software world, you're at level 1. There's only one way to go, and that's going up. You need to make sure that we have captured what are we actually building. Because if I'm only doing design, code, test, and install, I'm only going to be basing my effort, my historical effort, on that amount. If I'm doing software development end to end, I may be starting with software requirements. So I've got requirements for a piece of software that will be allocated into either hardware or software or to both. So I'm only going to be taking a look right now at the software development piece. And that would go all the way through to the end of software quality testing. Or maybe I'm doing software development end to end. You need to know what you're estimating in order to pull out the appropriate data and be able to normalize it so that you can base your estimates on it. There's no one-size-fits-all estimating approach. Depending on where you are in the actual project development, it's going to give you a different way of estimating. And there's a lot of different professional ways of estimating. So when we start out, we've got a much higher amount of uncertainty. If you're starting out with a concept of operations, which the US federal government uses as one of their high-level kind of project charters, or whether you're using a high-level product backlog, 90% of the Agile software development that's actually going on is a hybrid. We start out with some sort of a high-level scope. It's not just, oh, Carol, go out and build me something. No, there's build me a financial system that will do A, B, C, D, E. It may not be defined exactly, but it's not like me saying, oh, yeah, I want to build something. I've got a piece of land. Could you build me something on it? Oh, a house? Yeah, maybe a house, maybe a hospital, maybe an airline hangar. No, we've always got an idea up front what we're going to build. So at the very earliest stages, we can start doing estimating through analogy. Let's find something in our database that is kind of similar. And we can use that in the earliest stages of software development. We can use expert opinion all the way through. We can use parametric analysis, where we take a look at the data that we've got and we regress it back and say, what were the important cost drivers? We can, if we're partway through a project, we can do an engineering build-up because we know exactly what we're going to be building and we get more levels of detail. And then once you're into sustainment, which is after you've actually delivered something, we can start doing extrapolation from actuals because we should be collecting data as we've been going on. So there's not one-size-fits-all estimating approach. Lesson 5, quantifying software size is absolutely fundamental to a good estimate. So when we take a look at software requirements, so you've got your laundry list of all the requirements that a program needs. And some of them might be facilities, they might be hardware, they might be software. We just take our software requirements, and from there, we can take a look at 3 types of software requirements. These will go into my product backlog. So I've got my functional user requirements that describe the functionality. It answers the question of what does the software do? In user stories, it's something like, as a type of user, as a customer, I want to create a reservation so that I can start planning my trip. That would be a functional user requirement. A non-functional user requirement is how good does it have to be? Does it have to be high quality? Do I need sub-second response time? Do I need to introduce cybersecurity, encryption? Do I need to have this operate on multiple hardware and software platforms? Those types of things are my non-functional user requirements. And then I've got my technical requirements, which are really, how am I going to build it? Am I going to use Ada? Am I going to use .NET? Am I going to use Oracle? Am I going to use a package? What am I going to use? And all 3 of those really come into play when we're talking about software requirements and software development. So these go into really a definition of what constitutes my software development projects. And when I'm creating a software development estimate, it really consists of 4 pieces. The first is a software size estimate. What am I going to build? Makes a difference. From my size estimate, I can then build an effort estimate. How much labor is it going to require to build or renovate or install or whatever I'm doing based on the size? So once I've got my effort estimate in terms of the number of hours, the number of person hours it's going to take to actually do this, then I can come up with a cost based on labor rates. And the effort also allows me to come up with a scheduled duration estimate. So that's what constitutes a software development estimate. And from those, I can take my cost, my estimated cost. Typically, I need to make sure I've got multiple estimates done different ways so that I can triage those and cross-check. But my cost estimate, I also need to factor in growth. What is the expected growth of this project and the uncertainties? So from that, management teams can then take a realistic look and say, you know what? The cost looks too high. Or maybe we should break this up into different projects. And even if we're doing an agile software development, we're still going to have, from a very, very high level, a product backlog. So I can take a look at something and it would be similar to saying, you know what, I don't really know what I'm going to have in this house. I'm not really sure what the different rooms are going to be, but I need an estimate so I can go and get a mortgage. The same thing on software development. Is it going to be $1 million? Is it going to be $15 million? Is it going to be $75 million in terms of the software development cost and the effort it's going to take to build whatever I'm building? Number 6, we can estimate the product backlog using functional size. We can use something called simple function points, which is something really exciting to me. Simple function points takes away all of the requirements to do a function point count. Simple function points is a method that was developed in Italy by Dr. Roberto Melli and has now been standardized by the International Function Point Users Group. And whereas we used to take a look at all of these elementary processes and have to break them down, is it an input, an output, a query? Do we have internal logical files, an external interface file, and all of those things? Simple function point says, you don't have to worry about that. We only look at things like elementary processes, my adds, my updates, my deletes, my transfers. Those types of verb processes are my elementary processes. And each of those is worth 4.6 simple function points. I can take a look at what are my entities? What are the logical files? Okay, I need to collect data about customers and accounts. Okay, that's 2 logical files. From that basis alone, I can say, you know what? Each logical file, and this is part of the methodology, each logical file is 7 simple function points. I can really, really quickly and easily come up with an approximate simple function point size in the same way as I might come up with an approximate square foot value by sketching out a house. You know, I've got a sketchy floor plan. I don't know where the walls are going to go. I really have no idea what the rooms are going to be, but I can take a look at how big does this thing look like it's going to be. So for example, if I'm going to create, read, update, delete, that's what CRUD is. Create, read, update, and delete, plus have a data store. Then I know I'm going to have 4 elementary processes and 1 logical file, and it ends up being 25.4 simple function points. I can take a look at 10 unique reports. I don't know, are we going to have 5, 10, 15, 20? Draw a line in the sand. And so if I've got 10 unique reports, that's 10 elementary processes, it's 46 simple function points. I'm going to send data to another system or receive data from another system. Well, that's going to be 1 or more elementary processes. Even from the highest level product backlog, I can come up with a functional size for what the software should do. And now I can do it so easily because I don't have to worry about all of the nuances and requirements to do an actual function point count. So that was an interesting thing. Number 7, software development is subject to diseconomies of scale. That means in the equation where I have below, effort equals size put to an exponent times 1 divided by productivity. So diseconomy of scale means that my exponent is greater than 1. And if you look at effort versus size, it actually follows an S-curve. Productivity is my effort divided by my size, or my size, and you can see it's nonlinear, which means that as we get larger projects, the productivity ends up actually not as high. So as I get a higher size, my effort goes up. Well, that's obvious, but it doesn't go up in a linear manner. And why is that? Well, because the larger the project, the more people we have involved. And the more people we have involved, the more management is involved. And there's a relationship, an exponential relationship between productivity and size. So there's an equation that is the number of channels of communication. Every time you increase those, your productivity goes down. So, but there are areas, and I put some little orange markings on this curve. If you look at the size between 2 markings, you'll notice that the productivity is essentially linear. So if I am comparing to data that are between the lowest orange mark and the next orange mark, I could assume from an estimating perspective that that is linear. But I can't take something off to the right on the size chart and use that productivity against the effort, because it's not going to be linear compared to a smaller sized project. My estimate's going to be way off. Or if I use a smaller size project and I expect to have a linear response, I'm going to way underestimate. So this was another thing that's absolutely essential and is really unique to software development, because our software development costs are large based on the effort. And the effort is based on how much communication. This is something that's completely different from hardware estimating. It's completely different from facilities estimating. Software development is based on the labor and the communication and everything else. So it follows an S-curve. Number 8, Agile versus Waterfall, there's different cost estimating considerations. In Agile, the fixed variables are the cost and the schedule. You are given a certain amount of money and a certain schedule, a certain number of sprints in order to deliver an estimated scope. Whereas in predictive or waterfall, we end up with the scope being fixed and having to work with estimated costs and schedules. Now, as I said before, I believe that 90% of the Agile software development that's going on actually starts out with at least an estimated scope, an estimated size. We have something, I know within the federal government, they do the software requirements, at least at a high level in econops, and will fund or write a contract for that level of delivery. So we can do an approximate size. And at least when we find out it was wrong, as will be almost everything an estimate, it's not a prediction, it's not a guarantee. An estimate is a best guess based on the information we have at hand. So we end up doing a high level, very high level estimate of size from a ConOps or from a high level product backlog. Number 9, hybrid software solutions are non-trivial. We end up taking a look at, are we doing development, software development, or software procurement? And depending on what we're actually doing, results in a different estimating approach. So estimating the investment stage of software, and the investment stage is when you actually start the project through to actual delivery, and then sustainment is the second stage. That's when you're in maintenance and ongoing enhancement. So first question you have to ask is, do you know the software architecture? If you don't have any idea of the software architecture at all, we can only do a rough order of magnitude estimate. That's a very high level ROM estimate. If the answer is yes, then the next question is it going to be custom software development? And if the answer is yes, it's going to be custom software development, we can use those equations that I mentioned earlier, analogy equations, parametric software equations, that type of thing. Most software development is a hybrid. We might be doing some custom software development, some procurement where we're going to have glue code and things like that. So you may need multiple estimates that you need to put together to estimate how much should this software development cost. So custom software development, if the answer is no, we say, okay, are we using a standalone COTS package? And if the answer is yes, then we say, okay, we're procuring it, we're actually purchasing it. So we estimate that way, or are we leasing it in terms of software as a service? It's a different way of estimating. So if the answer is no, it's not going to be a standalone COTS package. We've got essentially 3 major options. We've got COTS products that we glue together. We might, and that's the service-oriented architecture. Or we may have an enterprise solution. That's my ERP, my enterprise resource planning, and that's things like Oracle suites or SAP suites or PeopleSoft suites. And we have different sizing we use them. We use something called, just escaped me for a minute, but we don't use functionality. Or we might have a data enterprise data warehouse, and we've got a different way of estimating that. So it's not a one-size-fits-all, you just go in and you do an estimate. No, it's taking a look at the different parts. So number 10, there's a continuum of development versus procurement. So we might have something that's 100% completely developed custom, or we might be enhancing our legacy applications, or we might have something on the other end that is completely procured, where we'd just be considering configuration, licensing, integration, and customization. And all software efforts, with or without system activities are separate. If we are going to have to do our hardware, we're going to have to purchase hardware and things like that. That's not part of our software development estimate. But all software efforts lie on a continuum between these two. And procured software involves this effort to actually configure instead of build, integrate, customize, and things like that. So we need to take a look at software cost estimating as the complex animal it actually is. So from Agile and cost estimation, you know what? Poor cost and schedule estimates can doom a project or initiative from the get-go. So if you're on an Agile team and you say, you know what, the cost estimators are crazy. They always come up with the worst things. I'm not going to participate with them. They just, you know what, nobody talked to them. You know what's going to happen? You're going to get what you disdain. You're going to end up with a poor cost and schedule estimate, which is going to result in targets that are wrong. So work with the software cost estimators. Help them understand. Help them deliver the highest quality estimate they possibly can. Because they're really your advocates. They're not your enemies. They're your advocates. Software cost and schedule estimates are especially challenging to regular cost estimators because of the nuances and the special things, the diseconomies of scale, and the team. So 3-letter acronyms and the types of requirements are going to be daunting. It's up to you, if you want to get good cost estimates, to work with the cost estimators on software development estimates. Communication between the two disciplines, between cost estimating and development, can lead to way better outcomes. And actually, and this may surprise you, software cost estimation is an actual professional endeavor. It can take, for some of the programs, some of the federal programs, months and months of data combing, of data analysis to get to a solid, realistic, and reliable data-founded estimate. So this is some of the stuff we've put into the ICEA cost estimating body of knowledge for software. Here's the different pieces, and I'm not advocating that you have to sign up for ICEA or that anybody needs to join anything, but it's important to know that there is a professional level body of knowledge based on proven principles. We went through and I combed and scoured and combined things from the Government Accountability Office, from the Department of Defense, from Defense Acquisition University, from the Navy Cost Estimating Center, from the Air Force, from all over the world. We compiled and created this software cost estimation body of knowledge, and it will be out for public consumption soon in the next couple of months. So we divided it and we took a look at what are the different areas that somebody should need to know. So lesson 0 is really an introduction to the curriculum. Here's what it is, here's what we've got in it. Lesson 1 really takes a look at the importance and motivation for having a cost estimation body of knowledge for software. You may be surprised to know that the amount of software code in an F-15 is so much more than it ever was in the past. There are projects for which software might seem like it is a minor point. There was a highway toll project that was done in the Netherlands, for which they built these expressways and they had these toll booths. The project ended up being delayed, ended up being over budget and behind schedule because of the toll booth software. Wow. The toll booth software, because they did just a trivial look at it and said, oh, let's throw in, no, what do you think, $1 million? Yeah, let's just throw in $1 million on our overall construction project for the software. Well, that small part of the project, which was the software part, ended up crippling the entire project. So lesson 1 really looks at the importance and motivation for having a cost estimation body of knowledge for software. Lesson 2 takes a look at the software development paradigms. How are we building the software? Are we doing it using Agile or 100% Waterfall or some combination between? Are we taking a look at it from an object-oriented directive? Are we looking at it from spiral software development? Those types of things are all covered in our lesson 2. Lesson 3, we've adopted a 5-step estimating process. The first one actually, the first step is to gather all of the available documentation. And we go through 5 steps based on a hybrid of what we found to be best practices at the Defense Acquisition University and the Government Accountability Office, which has done both an Agile guidebook and also a software cost estimating guidebook. Lesson 4 takes a look at what do we do to estimate the custom software development we're actually building from scratch. Lesson 5 takes a look at the definitions and really quantifying what constitutes software sustainment. It goes way beyond just software maintenance. And there's a whole school of thought in that. And that's covered in lesson 5. Lesson 6, we take a look at estimating the procured solutions. What are we counting? What are we configuring? How do we count and measure blue code? What are the different approaches? Software as a service versus commercial off-the-shelf products, the COTS products. Then we've got 3 kind of peripheral lessons that go and are used in all of the lessons. We've got a lesson X that's on software size. And in that, we take a look at if-pug function points, simple function points, cosmic function points, NESMA function points, use case points, object points. We take a look at source lines of code. We take a look at all of these different ways of measuring. And we also take a look at story points and t-shirt sizing. So all of these different ways of measuring software size or estimating software size. Lesson Y is a deep dive into productivity. What do we do? Where are the areas of uncertainty? What do we need to know about productivity? Because it's not a linear relationship. And lesson Z takes a look at 4 commercial estimating models. We take a look at COCOMO 2, which is now morphing into COCOMO 3. COCOMO stands for the constructive cost models, and that came out of the University of Southern California. So there's commercial estimating models that are available. That one's available for free. We also take a look at Gallerist's SEER-SEM model. We take a look at Price, and it's got a new company name now. We take a look at their estimating model, and we take a look at Quantitative Software Management, QSM, SLIM tool. And we take a look at what are the results of coming out with different estimates using the different commercial estimating models. So it's pretty robust. Might be something that if you're going to get into formal, reliable, and robust cost estimation, in other words, moving up those steps of the estimating maturity model, your software estimators or your cost estimators may want to take a look at this. It builds on prerequisite knowledge that ICEA already has in place. So in the body of knowledge that I developed, I didn't teach how to do parametric estimation or how to collect the data, or we touched on normalization, but not that much, how to do inflation and index numbers. These are all things that are already part of the cost estimating body of knowledge that's already in place. So we've built on this. So let's go back. Let's go back to that original thing that I talked about in the beginning. Data-based, realistic, agile development estimates can lead to positive project outcomes. So if we've got a standard estimating process in terms of taking a look at the size and the complexity and the capability as cost drivers, we can then end up creating realistic and reliable estimates that take into account growth, that take into account known and unknown risks, and we'll do cross checks to make sure our estimate is even realistic. We end up then with more realistic plans in terms of what do we estimate it to cost, how much effort, what do you think the duration should be, which can then feed into more realistic contracts and internal projects. It's not estimates based on we think or we want or we hope. It's based on data. That will lead us to better in-controlled projects with positive project outcomes. We can have anticipated and tracked project growth. We can take a look at the risks and mitigation solutions. We'll end up, if you have a good estimate, you're going to end up with more on time and on budget projects. It's a no-brainer. But if we don't do something about this, in Einstein's words, yeah, we're working with insanity. So a final note. Capers-Jones, as I mentioned, said, and I quote, "The software industry has the worst metrics and measurement practices of any industry in human history." Whoa, that's pretty daunting. That's really bad. My quote is, "Size and data-based software estimates are the key to better project outcomes and, in time, better metrics." So if we get our estimates right and we start measuring and tracking actuals, and we put them into a database where we can actually do proper comparisons, it's a win-win for everybody involved. So I'm at the end of my presentation now. This is my information. I want to say thank you for being a part of this. And I would be happy if there's anything in this presentation that you want. I'd be happy to share the slides with you. I've got a bookshelf full of articles I've written on function points, on functional sizing, on simple function points, on software cost estimation. So if you'd like any of that, or you'd like training, consulting, anything like that, I'm your person. One thing that I will mention that I didn't mention is that there's actually a certification coming to be a software cost estimator certified professional. I don't know what the acronym is going to be, but that is rumored, and I don't know for sure. It is rumored to be launched at the ICEA Professional Development annual conference, which will be in San Antonio, Texas in May. So if you go to ICEA online, it will, you can find out all the information about that opportunity that's coming up.
Carol, we appreciate your time and your expertise. Thanks for joining us.
Thanks. And if as I said, if anybody has any questions, you may come up with it sometime down the road, next week, next month. I'm happy to answer your questions or help you out with anything you need. And thanks again, Susan.